Yeah, so welcome back everyone. So today we'll be looking at some of the basic mathematics that is required for our encryption algorithms. Okay, so first one will be the modular arithmetic. What it says is if we have an equation like A equals to B mod n. So what it means is if we divide A by n and B by n, it gives the same remainder. For example, if we have 24 equal to 12 mod 12. So what it means is if we divide 24 and 12 by this 12, it will give the same remainder 0. Okay. So again the example, if 13 equals to 1 mod 12. If we divide this term and this term with 12, we'll get the same remainder as 1. So this is the basics of modular arithmetic. So we'll look some of the interesting properties that might help us in understanding the concepts well during our encryption algorithm. So how exactly they work. Okay. So first one is A equal to B mod n if n divides A minus B. Okay. The second one is if A equal to B mod n and C equal to D mod n. Okay, assume this thing to be true. So A plus C is equal to B plus D mod n. I'll not go into the definition or what we can say proof of this statement. You can just remember it just for the sake of this algorithm, or you can just explore these rules on your own. Similarly goes with the subtraction as well. If A is B mod n and C is D mod n, then A minus C is equals to B minus D mod n. And the last one is not actually the last one. There are quite many interesting properties of modular arithmetic, but I am taking only those which will be helpful for our algorithms. So if we have A equals to B mod n, sorry for my handwriting, it's new to me, and C is equals to D mod n, then A into C is equals to B into D mod n. Okay, so these are the properties that will be required while discussing our algorithms. Okay, now we'll come back to some other properties. Let me erase it. Please bear with me for some time. Okay, so we have a term called as Euler-Toshan function. What this function gives us is, this is how Euler-Toshan function is represented. If we give this any number to this function, it will give us a number x. X is the number of numbers which are co-prime to n. Okay, suppose consider we take 5. So the Toshan function of 5 will be 4. So like all 1, 2, 3, 4. All these numbers are co-prime to 5. They don't have any common factor between them. Okay, so if now we'll take some special cases. If a prime number is given as an input to a torsion function, so its output would be always the given number minus 1, because as it is a prime number, it doesn't have any other factors other than 1 and itself. That's why, see, here 5 is the prime number and its torsion function will be 4. So for 7 it will be 6, for 11 it will be 10, and so on. Okay, now the question will pop up in our mind: what if this number given here is not a prime number? So we already know the basics of mathematics from class 10th. Any number can be partitioned into its prime factors. So 12 can be written as 2 square into 3. Okay, now for this 3 we can directly give as 3 minus 1 equals to 2 according to this property. Now how to deal with this when there is a torsion function of any prime number raised to the power n? So its formula is p to the power n minus p to the power n minus 1. So if we want to calculate torsion function of 12, it will be 2 square into 3 and its torsion function. Okay, so it will be 2 square minus 2 into 3 minus 1. It will be 4 minus 2 into 2 equal to 4. Now we can see there are 4 numbers which are co-prime to 12 starting from 1. It will be 1, it will be 5, it will be 7, and it will be 11. These are those 4 numbers. Fine, clear till now? If you have any doubt, you can just comment in the comment section. So yeah, these are all the basic that is required for our encryption algorithms. So let's start with the RSA algorithm in the next lecture. Thank you.